Hi, in this video we're going to have a look at this FX-Audio DAC-X6. So in a recent video you'll know that I had a look at this FX-Audio FX98S Pro, which is a 16-bit USB DAC that outputted either straight into line out or into headphones at the front. This device is a 24-bit DAC and the connectivity on the back is a little bit different. So we've got the PC USB input here, but it also takes optical and SPDIF, and then you've got your line out at the back and also the headphone output at the front. So this DAC is available for around £70 from Banggood, and the links are down in the description, so have a click on those if you are interested in looking at some DACs for your PC. But this has some really nice specifications. So yes, it has the USB, coax and fibre optic inputs at the back, and then we've got a 6.35mm headphone output at the front, which is designed to drive between 32 ohms and 600 ohm headphones. So one thing that I pointed out when I reviewed this lower cost device is that it wasn't very good into my high impedance headphones. This one can output 90 milliwatts into 600 ohm headphones and all the way up to 1 watt into your 16 ohm headphones. So it should have a really powerful headphone amplifier. It'll be interesting to see what they've got inside. And then we supposedly got a really good signal to noise ratio, greater than 105 dBs. And then it comes with an AC adapter to power it from your AC supply. So it does need a separate DC supply. And then we've got a little bit of information about the USB connectivity that's in it. So this video was brought to you by Coupons from Asia, and if you are interested in buying something from Banggood, have a look at this website first and have a look to see if there are any current discounts or discount codes available for a product that you're after. So I've been using this DAC for around 3 weeks in the lab, connected to my PC and also to speakers and headphones. And I would say that when connected to speakers, there's not a huge amount of difference between these two devices. And that's generally because there is background noise in the lab and in any listening room, which means that you can't hear the true noise floor of these systems. So any very small differences, LSB type differences on 16-bit DAC are going to be lost against background noise. But when plugged into headphones, that's sort of when you get your true audio experience. You can block out all the external noise and you've got your speakers effectively very much closer to your ears, so you can hear the differences very closely. And that's where this one really shows off its true colours. And I'm not sure how much of that is down to the fact that this is a 24-bit DAC over the 16-bit DAC in here. There's a very large argument that always goes on between 24-bit and 16-bit DACs. For audio mastering with ADCs, obviously 24-bit ADC is brilliant because you can capture a very large dynamic range, and then when you edit your audio, you can compress down to the audio range that you're interested in and just basically get rid of those LSBs. But for the DAC, your audio has already been mastered to use the maximum dynamic range. So it may not have made a huge amount of difference, but I think the headphone amplifier and generally the circuit design in this is probably significantly better. It is a bigger device. It'll be interesting to see what's inside. So let's take it apart and have a look. So the overall construction of the electronics is fairly sensible actually. So at the bottom here we've got our power supply circuitry. So we input a 12 volt DC input here. It goes straight into a 3.3 volt linear regulator for some of the electronics at the back here. We've got 3 charge pump controllers for generating negative 15, minus 5 and plus 15 volt rails for some of the analog electronics on the board. And we've got a couple of linear 5 volt regulators dotted around the board as well. We've got our main bulk capacitance here, which are solid aluminium capacitors from Capson, so not too bad at all really. And then we've sort of got our input circuitry at the back here. So at the back here we've got our USB input, which is powered by an SA9023 USB streaming controller, and that is a 24-bit capable device. And it appears to enumerate in Windows as a USB Audio Class 2 device, so it just means you plug it in and it just automatically works, which is great. And then we've got a Cirrus Logic 8416 SPDIF decoder here, and that takes the input from the optical input and the coaxial input here and outputs a PCM stream which can be interpreted by the DAC. And the DAC is a Cirrus Logic CS4398 24-bit 192 kHz DAC, so quite a nice part here. And it's got various oversampling modes if you're not outputting 24-bit or 192 kHz audio. And then that feeds into our volume control electronics here. So we've got a volume control, which is a true potentiometer rather than a digital volume control, based around this op-amp here, which sort of takes care of the possibility of the tone being controlled by adjusting the volume. And then basically that gets output to our line output at the back here, and then also into our headphone amplifier, which is a Texas Instruments TPA6120A2. And that's a high fidelity, high dynamic range headphone amplifier, and it's basically got a pair of current feedback amplifiers in there which give a high bandwidth and sort of low noise performance. And then we've got a little op amp here as well to take the input from the electronics here and feed it into the headphone amplifier. So really quite a nice design. It's got some protection for your headphones with this relay that is actually cracked on here, so this has had a bit of impact. I'm not quite sure what happened, but it still seems to work. I might replace that for another part. But that stops you blowing your headphones up when you power it up with headphones attached. It takes a while for the DC rails and the AC coupling capacitors between devices to sort of stabilise, and that normally results in sort of a pop sound in your headphones, and that's protecting that. But overall, yeah, nothing to complain about really. We've got our op amp here, which can be replaced with one of your choice, because this basically outputs directly to your line outputs, so that's your final output. And a lot of people like to tweak those op amps, so there's a possibility of doing that with that socketed op amp. But yeah, generally speaking, not too bad at all. The construction looks fine, and fairly reasonable design choices. I'm not quite sure what linear regulator did go in this place before, but it's been linked out with a 0 ohm link. They obviously decided that they didn't need that in the end. So overall, I think this is a really nice device. It's made from aluminium, so it's all a nice case with black anodized coating. You can get it with a silver front panel if you like, but I think this is definitely a worthwhile upgrade over the FX98S Pro that I reviewed last time. And at £70 it is very good pricing in comparison to what you typically buy from your hi-fi retailer. Obviously, if you're happy with the sound from your sound card, then you may not be convinced by spending £70 on something like this. But if you went to your hi-fi shop and looked for a 24-bit DAC with a headphone amplifier, you're typically looking at spending £250 plus on something that would typically have the same design basically as this. So this is actually very good value for money. And if you're into your hi-fi gear, you obviously know that you can spend many hundreds, if not thousands of pounds on something similar to this. So I do think it's very good value for money, and the links are down below in the description if you're interested in having a look at this and also this device here that I reviewed last time. So in the future, if there's any interest, I am thinking about revisiting an old project which I started all the way back in 2012. And I got a long way into the design of this, and it was a audio DAC, headphone amplifier and preamp for my hi-fi that would take in USB, SPDIF, optical, and also I think analog inputs, and then out into the hi-fi amplifier. And basically it was designed around some Wolfson WM8741 DACs, so these are really high-end 24-bit DACs, and I designed all this circuitry, many pages of it, headphone amplifier, circuit protection, everything was sort of in there. The only thing I haven't got on here yet is the user interface. And then I made the mistake of starting to prototype this design, and so I got into prototyping all of this. I've got some analog stuff here, there's another board somewhere, it's got an OLED for the front panel, and this worked really well, and then I sort of lost interest because it worked. I had it actually like this connected up to my hi-fi, and it worked, and then I kind of lost interest. So many years later now, 6 years later, I'm thinking about revisiting this and actually completing it. And I thought it'd be quite nice to sort of break it up into sections. So we'll have sort of a discrete PCB for each block with some nice interconnects between each of them. So we'll have sort of the input circuitry, power supplies, the microcontroller for the UI, might have an FPGA on there for doing some of the signal processing. We'll have a DAC board, and yeah, I was thinking we might build this up in blocks and then build it all into a hi-fi case. So if there's any interest in that, leave a comment down below. But yeah, audio is something that I am interested in, and I did really enjoy building this up. But I didn't get round to completing the schematic or doing the PCB layout. So if there is interest, that might spur me on to actually get this completed. So I hope you found that video interesting. The links are down below for the 2 DACs that I reviewed if you are interested in having a look at those on Banggood. We'll have a look at the lighting project again shortly, but until next time, thanks for watching.